Like I said, for the past few years I have been involved into some administration at home and not being able to attend to Alice, and I reverted back to this for the last few months. So one is in the process of resuming this work, and that's it. Now, we are a small group in a place called University of Rajasthan in Jaipur, and by and large we are working within the Indian PMD collaboration, where there are about 30 people, or maybe a little more, who are working in this collaboration from different institutes within the country. But I belong to this university called University of Rajasthan, which right now we have only 2 faculty members and a few students. Alice experiment has started recording data only for the last few years, but the first time ever that somebody gave a prediction for the interest of flow as it stands now is already 20 years ago. Flow was observed in a different form even earlier, and different experiments since last 20 years have measured an isotropic flow, and in the process learned what actually does this physical quantity mean and how to measure it better and better. Something that you already know, in each measurement there are 2 important attributes. The measurement should be precise and the measurement should be accurate. So we need that our measurements are both precise and accurate. And right now, the measurements of the physical quantity which describes or which quantifies flow, their accuracy needs to increase. And if the accuracy needs to increase, then we will be able to converge on a particular value. This is as far as the experimental aspect is concerned. There need to be theoretical developments to be able to explain subtle phenomena of how this anisotropic flow changes with kind of particle, transverse momentum of particle, rapidity of the particle, on various properties, kinematic and dynamic properties of the particle. So those are developments which still need to take place to be able to get a complete picture of how an isotropic flow evolves in a nuclear collision. When 2 spherical nuclei collide, there is a region of overlap, and that region of overlap is not symmetric about all directions within the azimuthal plane. Now this asymmetry, because of this lack of uniformity along all directions, and if we assume that whatever are the particles in this region of overlap, they are in equilibrium. So it's like an equilibrium of gas molecules in a box. Now if they are in equilibrium, then along the smaller direction they tend to exert a greater pressure and greater force, and along the larger direction smaller force. It's just like given any asymmetric shape, where is it where it will like to squeeze out faster from. So that is the kind of thing. So that produces in the final state an isotropy amongst particles which come out of that region, and eventually amongst particles that we observe. The reason it is of interest is this equilibrium and the subsequent evolution helps us determine whether it was a quark-gluon plasma which was formed or whether it was a collection of hadrons. So all that is described by saying that the equation of state is a partonic equation of state or a hadronic equation of state. So those are the kind of differences. But equation of state is the magic phrase. It's like this. And allow me to go a little backward in time. For any such things, when we study nuclear collisions at high energies, and we are looking for quark-gluon plasma, it's a little bit like looking for a needle in a haystack. What makes it more challenging is we don't know what does a needle look like. So we don't really know what is it that we are looking for. So this is how it started. Over the last 2 decades or so, all the experimentations have thrown a lot of light on this. And now people do understand certain features about nuclear collisions. However, there is no one universal model which can explain all the data that we observe in the collisions. Now, if there is lack of this universality, we think we don't understand it completely. And if you allow me to take an example from outside the domain of science, there was this Sufi philosopher called Jalaluddin, who had narrated this story about 6 blind men in a dark room and an elephant. I'm not sure if you've heard of it. As the story goes, what happens is there are 6 blind men in a room, and there is an elephant, and each one of them is asked to describe what does the elephant look like. So one of them touches the leg of the elephant, and he says the elephant is like a pillar. The other one moves his hand around the body of the elephant, and it says elephant is like a wall, and so on. Now the moral of the story is each one of them are right. The thing is their total comprehension was limited. Now the wise man is somebody who can look at all the data and construct the figure of the elephant. As I see it now, this is the story of heavy ion collisions and search for quark-gluon plasma also. So we see all different things, and that overall universal picture still has to come. And it's not easy for me to answer what is the time frame in which we should be able to do it, but the way things seem to be moving or sort of converging in some places, I would say in the next 5 years or so of that order of time, one would narrow down the differences between a wall and a pillar, you know what I mean? So, but actually, when is it that we can converge? It's not easy to say that. Everybody knows CERN because of what happened in 2008. There was so much of publicity in the newspapers about this and so on. Mostly it all started with negative publicity, and this is something I'd like to share with you. In 2008, when everybody was writing something will be created, it will gobble the earth and so on. So I had these friends who have nothing to do with physics, and they asked me, Sudhir, is this pertaining to the experiment that you go to CERN for, to Geneva for? And they didn't say so. I said, yes. He said, there is so much of wrong rumors being spread around every day in the newspaper, why don't you clarify it? So I said, look, I can't stop people from talking whatever they do. And they insisted, and they made me write an article for the newspaper. And then I put that in the newspaper. And all of a sudden, the whole country was full of news about CERN. And so for the last few years, while I was in an administrative job in another university, in the office right opposite yours, there are these students who are all working in the LS offline with Federico, etc. And the purpose was people need to be exposed to good science. And one of the things which is probably missing the world over, which eventually also affects our value system, Panos, is an appreciation for good science and the laws of nature. And this is something which is close to heart and I feel reasonably strong about. that people should understand the laws of nature. I'm not saying they should necessarily do physics, but people should understand the laws of nature.